let's jump into Alberto and your presentation. The presentation, I understand, will be about the how common agricultural policy projects and agriculture processing can be done at scale with Copernicus data space ecosystem and Copernicus data.
That's right.
Thank you.
Well, first of all, thank you for inviting us to this user review. And yes, in this presentation, I'll try to present ourselves, present our work in relation with the area monitoring system we run in the paying agency of Castilla y León. Then I go on how we use the CDSE data and services, and then I try to explain a test we run with a batch statistical API provided by the CDSE. Okay, I think I can use this. Is supposed to? Okay. Yes, first, introducing ourselves, let me give you a brief overview of how the Common Agricultural Policy is organized in Spain. The Common Agricultural Policy in Spain is coordinated by the National Ministry of Agriculture through the coordination body called FIGA. In Spain, there are 17 paying agencies, and Castilla y León, the Regional Ministry of Castilla y León, is one of these paying agencies. Castilla y León is the biggest region in Spain and the 12th paying agency in Europe, so we are quite big. And about the Agrotechnological Institute, the institution I work in, we are a public entity that belongs to the Regional Ministry of Agriculture, and we give support in digital solutions and digital technology to the Regional Ministry of Agriculture. In this regard, we run the area monitoring system for control and checking the CAP interventions. We develop our own system in our own premises, but we took advantage of some European projects for this. So how would you get involved in this area monitoring system? Well, by 2014, we were developing a crop classification map based on Earth observation imagery and machine learning algorithms. And because of that, we were involved in some European research projects, 2020 projects, that help us to develop our monitoring system. This help us also to get involved in the project in ISA project, Sen4CAP. I guess many of you know about this project, but Sen4CAP project was the project that demonstrated that Copernicus information can help in the checking and control the area-based CAP aids. So we learned a couple of things from this project thanks to this ISA project. So we were doing this, and in 2018, the European Commission encouraged member states to go for monitoring and establish a three-year period in which the member states could progressively increase the area monitored. So is what we did, and we ended up in 2021 following all the parcels of the area subject to CAP subsidies. And we've been doing this till 2024, where the new CAP programming period entered into force. And this forced us to adapt our monitoring system to the new requirements in the strategic plans. So we have to increase our capabilities of monitoring this intervention. And of course, the enhanced conditionality that this new programming period brought. So we adapted our system to these new interventions, but more or less the area monitored is almost the same. Well, to tell you about how we use the data, the Copernicus data, I had to tell you the story because we started downloading Sentinel-2 images from the OpenEO system. We did it manually. We checked visually the less cloudy images and then download to integrate it automatically in our system. We found here some limitation. We found some delays when trying to get back in the data in the catalog. So we experienced some delays. So we decided move towards the planetary computer repository. We moved to this repository, and as well we use it to automatize the download. A planetary computer implementing an Stack API that help us to discover and retrieve this information. And apart from that, we started to download Sentinel-1 products, and more precisely, the radiometric terrain corrected product. So we were doing this, but we found some data gaps. And we started to explore why these data gaps, where these data gaps come from. But we decided go for the CDSE services. So up to now, we are using in our system the CDSE APIs and capabilities. In 3 ways, we use OData to download the data, to download Sentinel-2 images. In this case, we do an extensive use of OGC services, and we make some tests with OpenEO. The move towards the CDSE was quite easy because we were used to working with Sentinel Hub, so it was quite easy to move towards the new system. So starting for the OpenEO, how we use this system? Well, we are involved also in another European project, H2020 project, called Tools for CAP. One of the objectives of this project is provide managing authorities and paying agencies with tools that help them to evaluate and redesign the new generation of the strategic plan, CAP strategic plan. So we thought that one case study could be perform a soil organic carbon map that could help evaluating some intervention, eco schemes intervention in the strategic plan. We tried this, we performed this test, and we consume almost more than 10,000 credits, and with a maximum daily consumption of 2,500 credits. Apart from that, we are running the national official FAST tool. FAST tool is a tool that is aimed at helping farmers to perform better nutrient plans application. So in this case, we use a statistical API from the CDS and the OGC service as well. So going back to this slide, I'm telling you now how the area monitoring system operates. Sorry. So to give you an idea, the Castilla y León area monitoring system is split down into parts. One is on the side of the management segment, and other one is on the remote sense segment that is more focused on the use of Earth observation data. Well, this is how we use more or less all the services, but I want to focus on this part because it's the part where we perform the test. In this case, what we do is intercept every single parcel that is applying for subsidies with all available image data. So we can extract some statistical metrics on many spectral indices, NDVI, NDTI, TC brightness, for instance. There are the list is very long, because we need to elaborate we had to check the evolution of this parcel to see if this parcel is compliant with the requirements in the strategic plan. So the system runs this way. So there is an upper level where the upper level could be the Copernicus ecosystem, where we can we download the Sentinel-2 imagery from, and the down level is the database from the paying agency, where we get the geospatial application of the farmers. Then we extract the metrics in this way. When the campaign starts, we get the GSA, the geospatial application from the paying agency, and we extract the metrics from the beginning of the season, from the all available data. As the campaign goes on, we have a new situation. We have old declaration that remains the same, but we could have new applications. So we have to run the old ones just with the new images we acquire, and the new application with all the temporal series. So we have this. This is a way in which we try to optimize the resources we have. So that we can track this evolution of the parcel. So in view of this, we ask our colleagues in Synergize to help us in this test, and we run this intersection with the batch statistical API. So we set a sample of more than 1 million featured geometries, parcels, and we upload it in the statistical API. We ask them to run the process in 1 year period. So that I want to stress here this concept of item, because I think it's the unit we use to compute all the metrics. Item, I mean the combination into geometry and date to process, image to process. So in this case, we obtain almost 100 million items to process for this temporal series. This processing took 34.5 hours, and it took 7.8 million processing units. And the performance is amazing, really, because it's more than 3 million items per hour, so it's amazing. And then when this is processed, we had to download the results. That is one JSON file per geometry, and we had to include this, integrate this result in our database. So keeping in mind these numbers, we imagine that we start with the first execution of our system using CDS. These are real numbers for the execution of 10th of April this year. So in this case, we had more than 300,000 geometries that we should be able to upload to the system. We don't know exactly how long would it take to upload this information, this amount of information, and then process it. In this case, we should process more than 7 million of items, and we should process it against this period of time from 12th July to 9th of April. So with the performance we get in the previous test, we estimate a processing time of 2 hours, more than 2 hours. If we compare it with the performance we are getting in our system, is almost 5 times less. So the performance is very, very high. we found here some difficulties to estimate the time, the processing unit we have to run. And then we have to download this information that probably took more than 6 hours and then integrate it in our database. So that took more or less 4 hours. So this process, we have to do this process every time we run the system. So in view of these results, we saw some strengths and some remarks, to say so. The strengths are very clear. The performance of the system is amazing. And the CDSE provides vital information for a paying agency. And the OData API facilitates a lot the retrieving and the automatization of the process, the downloaded process. The OGHC services are very easy to deploy and very easy to integrate in all our application. This is our main conclusions and remarks is that, well, we have already a system developed in our premises. So if we want to use these CDS services, we have to redesign the system because the time we use, because the system has high performance, but the time we use to upload, download, and integrate these results in our system balance the result. So this is key. Yes, and one thing critical for us is the estimate or the processing unit we are going to need, because we can take the risk of running out of processing unit in the middle of the season. So this is critical for us, and this is one of the remarks we saw in this test. And of course, and for OpenEO, we can go into details, but we think that having a share of quota to test code testing, just to be sure that there is no mistake in the code, could be desirable. So this is more or less, sorry for the, I ran out of time, but.
Thank you very much, Alberto, for this very...
So yeah, my name is Jeroen Degerickx. I'm a researcher at the Agricultural Applications team at VITO Remote Sensing. And I would immediately like to dive into this presentation by showing this picture. This is probably how most of the cropland in Zambia must have looked like early 2024. So there was a slight delay in the onset of the rainy season, but in the end, farmers received some rain and their maize crops started to develop on their fields. And then unfortunately, this happened. And I want you to look at the blue line, comparing rainfall received in 2023 compared to 2024. After this initial peak of rain, all rain ceased for the remainder of the growing season. And it's completely led to complete failure of maize harvest across the country. Luckily, the government quickly realized this and declared the drought as a national disaster that year. Only problem is, where do they need to send help? They don't know where maize is grown in their own country. They do not have high-resolution, reliable crop maps. Likewise, the International Center for Maize and Wheat Improvement, CIMMYT, they are very active in this region, distributing seeds of drought-resistant crops to farmers, encouraging farmers to adopt other farming practices to be more resilient against droughts. But they simply do not know whether these farmers are actually planting their seeds. They don't have any information about the crops that are grown there. And this is really where WorldCereal comes in. So we are an ESA-funded research project. Maybe most of you have heard about our project through the global products that we already produced for the year 2021. So for that year, we have global products for cropland and crop type at 10-meter resolution available. But what is really new here is that we're also in parallel setting up a fully customizable crop type mapping service for anyone to use to produce their own crop type maps for their region, for their season, and for their crop types of interest. And this is really where we made the decision to fully go for an OpenEO implementation on the Copernicus data space ecosystem. So mapping crops from space, although it sounds relatively easy and not too complex, there are quite some steps involved, starting from collecting data on the ground to know which crop has been grown on which location during which season. Once you have this location, for each of those, you need to collect relevant time series of satellite data in order to then train a crop identification model fully customized to your needs, and then in the end apply that model to your region of interest. So those are the steps that are involved, and all of this has been integrated in the WorldCereal processing system on the Copernicus data space ecosystem. And that is really to lower the burden and the obstacles for non-expert users to produce their own customized crop type maps. So no installation is required for them, no local processing. They don't need to bother about setting up processing clusters themselves. They can freely produce their maps suited to their needs. So going a bit more into detail in these different steps. So I won't dwell too much on this step as it's not that relevant for the audience right here. But basically we have an online portal where we gather and harmonize all reference data sourced from different organizations around the world. We completely harmonize it, make it available to everyone to retrieve the data, use it for your own crop mapping applications. You can explore and download the data and even upload your own private data sets, which are only for your own private use, which you then can combine. I mean, you can combine the public data with your private data to then train your customized model. In the case of CIMMYT, we are actively helping them out to collect reference data that is ready for use for crop type mapping using this GeoQuest application developed by IASA, and they have a demo later today at the ESA booth about that if you want to learn more. But what is more relevant for this audience, I believe, is that, okay, once we have the reference data, we have installed a full end-to-end pipeline to extract the relevant time series for the inputs that we need for crop type mapping. So on the right, you see that we use Sentinel-1, Sentinel-2, the Copernicus digital elevation model, and meteorological data from the Ag Era 5 ECMWF dataset. That last collection, that is something that we needed to add ourselves to the CDSE. It was not natively supported. So we simply built a stack collection around that, and using the OpenEO load stack functionality, we can easily ingest also that data set into our workflows without any problem. So yeah, OpenEO really takes care of, for each of these reference data locations, loading the relevant data, pre-processing it according to standardized processing schemes. And then we put all that data available to our users in a public S3 bucket where they can immediately retrieve the relevant time series and start training their model. This model training, this is a generic scheme of how it looks like. We have a full end-to-end demo notebook on how you can train your models for your area of interest. If you want to learn more, use that QR code in the top right of the slide. So basically what a user needs to do, choose their region and season of interest. We automatically extract the relevant public reference data along with the pre-processed time series. We apply a globally pre-trained AI foundation model on top of those time series to extract relevant features for crop type mapping. So it's the Presto model developed by NASA Harvest. So you have these 128 Presto embeddings. You then, as a user, need to select the crop types you want to include in your custom crop map. We train a simple pixel-based cut boost classifier on top of these Presto embeddings. And then it gets really interesting also, again, for this community. we allow the user to directly deploy their custom model, their private model, to an OpenEO bucket on CDSE. So that's safely guarded by their CDSE credentials. So only the user that has trained the model has access to the model. And it can be directly plugged into an OpenEO process that generates a crop type map based on their model. Again, in order to generate that model, we've encapsulated the full workflow covering data loading, pre-processing, feature extraction, meaning applying this AI foundation model Presto, and then applying your custom crop type classifier. We've embedded all of this into a single OpenEO user-defined process. For the ones not familiar, I always compare it to a recipe from a cookbook. It just contains like the detailed instructions on what needs to happen on a certain data set or for a certain region. And then OpenEO takes care of everything. The nice advantages about this is that it's hugely scalable. So at the moment, we are producing crop type maps for France, for instance. It's running as we speak. We simply chopped up France in a lot of 20 by 20 kilometer processing tiles, and we're simply applying this rather complex, I would say, processing pipeline to each of these blocks, generating a crop map for the entire country. Of course, you can, sorry, I need to go back. I wanted to highlight also that users that want to produce really large areas can also apply for additional funding through the ESA network of resources, because since our WorldCereal processing pipelines are embedded in this OpenEO process graph, you can easily request for additional funding through the ESA network of resources to run these pipelines. I also want to highlight the ESA Apex initiative. So there, the idea is that they really want to promote the sustainability of research projects funded by ESA. So whatever workflows developed by these projects, they can be encapsulated within this Apex platform. WorldCereal is among them. So what happens, we have automated integration tests. So whenever something changes in OpenEO or at CDSE, we automatically get notified, hey, your workflow is no longer compatible. Or whenever the OpenEO team wants to push another release of OpenEO, they automatically check whether their changes are not breaking our WorldCereal processing pipeline. So this is really neat also for us as processing providers, I would say. And then a last advantage there is really the user friendliness of the application. So what we've done is build a user interface around our processing pipelines. So users can just go to this link, authenticate with their CDSE credentials, and just launch any custom processing job for their area of interest. And that looks like that. So you can just draw a bounding box, specify which season you want to process, and then hit enter, and then automatically the jobs will be submitted to the CDSE backend, and you will get notified when the processing has been completed. You also can request a list of your processes, and then immediately click the download link to download your ready crop type maps. So I just want to highlight that this OpenEO and CDSE integration of WorldCereal really allows us to be extremely flexible and scalable. So by the end of 2026, we're planning to release another set of these global products. So really demonstrating the ultimate scalability, I would say, of the CDSE. So going to the global scale, always a very nice challenge also for our in-house OpenEO team. And together with our use case partners, we are really teaching them how to use this system for any region in the world. And as I said, really lowering the burden for these non-experts to start working on crop type mapping for their area of interest. So that's mainly what I wanted to say. If you're interested in very specific aspects of the WorldCereal project, we'll be here throughout the entire week. So feel free to get an overview of our contributions through that QR code. And with that, I would like to thank you for your attention. And here's again a list of resources you can consult if you want to learn more. Any questions?
Thanks for the kind introduction, and also many thanks for the invitation. You invited me to stand here and speak as a customer and as a large user of CDSE. So I have prepared. Can I click here, or where is it?
There is a pilot.
This one. Looks like that one. Cool. Yeah, I prepared a brief introduction to Brockmann Consult for those of you who don't know the company, and I somehow disregarded the advice to not to put too much text on slides. So be prepared to see a lot of text. I just decided not to read out everything because I didn't know what to delete. And maybe it's a valuable resource also as inputs for afterwards, because this is the user review. So I collected inputs from throughout the company, and I thought maybe I just leave it there and then you do whatever you like with it. Yeah, Brockmann Consult, we are a small company, 40 employees. We have been around for quite some time, since 25 years now almost. It's well established in this ecosystem of EO industry, I would say. We cover the downstream market, I would say from ground, well, a bit beyond after ground segment to the end customer. So it's quite a large stretch. And we have developed a large customer basis, mainly in Europe. So some of the highlights you see there. So we have been developing Snap for quite long together with ESA. We are Copernicus provider and downstream service provider for the marine service, for land monitoring service, for the atmospheric, for the climate change service, not for the atmospheric one. We created a Python ecosystem lately for analysis-ready data, and we operate several platforms in this ESA ecosystem. So I would say we are a different kind of user. If you think about the other applications, that's stressed a bit. We take away the burden for the end user. We actually would consider ourselves experts enough to deal with the complexities. We have a different user profile and requirements for a platform like CDSE, I would say, and you will see in a minute. So that's the three pillars, not going into details. So we do software, as mentioned. We do geoinformation services. So we always say we understand both sides of the story, not only the engineering, but also the remote sensing part. So we have a focus on water quality, and we have expert knowledge. That's where this consult comes from. It's a bit misleading today because we do a lot of development and service provisioning and not only consulting. And you see on top there many customers, including, I just spot the VITO logo. So we provide services and to many of them, and ESA, of course, among the larger ones, but also Copernicus and the Commission. Okay, that's a brief overview of what we are doing there, and I will have one more detailed example. So the Snap and CCI toolbox integration has been presented here earlier. So we are part of this Jupyter ecosystem, and we try to make available these tools together with the partners of CDSE. We have these Xcube data stores. I mentioned the Python ecosystem. It's an open source system that builds on top of X-ray and Dask, and we make data access easier for users. And in this respect, we leverage the data offer and also the catalog service offer, and rely heavily on that these services function reliably and scalable. You also see EOPFSAR. So we are part of the sample service. We are developing Python tools also for the new product format, and working already with that. It works also in this ecosystem and in the viewer, and this has also been demonstrated here on Living Planet. So then a large part of our business is Copernicus services. That's Copernicus land monitoring service. We do operational production of lake water quality. It's based on Sentinel-2 and Sentinel-3 actually, 10 daily products global. So that's huge. We have to process a lot of data, but it's sparse because there are large regions where you don't have large lakes or fresh waters. Then that's an interesting example, fire burned area for the climate change initiative for ESA. My remark somewhat relates to this because it processes the entire archive actually. And the result is a day of burn and 20-meter resolution. You search for fires, you start with a seed, and then you look through the entire time series, which means you process 2 petabytes of data for 1 year, I think. And we also started naively, let's say, but we ended up processing the same chunk of data several times until we basically re-engineered everything so that we load all the data and then basically turned it on the head. And then there's the detailed example. So Copernicus Marine Service, I chose it because I'm a marine scientist and I like the images most. So that's the operational production of high resolution coastal products. It's water quality parameters of all European coasts in 100 meter. It's also based on Sentinel-2 and since 2020. You see the details there. So it's a daily level 3, near real time, next day. So that's really operational production. Of course, we rely there on the data access and availability of data, but also on the reliability of resources. We do monthly composites, level 4, so that you have nice images of that. And we do an automated screening, and there's an optional operator interaction in case there's any quality control problems. And then we disseminate this to Mercator Ocean. That's the example now. So that's monthly averages. That's the Northwestern Shelf. Maybe you would call it North Sea, but plus Channel and Irish Sea. Here you see RGB. And then we produce turbidity, which is, well, the particulate substances basically. And from there, you can also go to chlorophyll. So that's the algae content, if you like. And that's high resolution or relatively high resolution. It's only, as you can see, produced at the coast in a 20-kilometer stretch around the all European coast. So what's behind the scenes? Of course, there's a processing chain. That's where the text starts. You start from level 1C. We do atmospheric correction because for water, you need a specific atmospheric correction. Then we do all kinds of merging because you've seen a seamless product throughout the different Sentinel-2 scenes. And then we do a level 3 and level 4. So that's a lot of not only data access, but also processing. And particularly the atmospheric correction is a heavy step here. And the processing system, that's why I mentioned this before, we are not using any high-level OpenEO Sentinel Hub APIs offered there. We have our own processing system. It's a Hadoop-based. It's pretty proven operationally. We use this for many years, and we use the Creodias offered services, and we rely on these low-level services rather. So we need VMs, scalability, and a catalog and S3 access. That's the most important things for us. And we do this, the control is done on premises. So the control node we run at home, and then we use the compute nodes on Creodias dedicated hardware. Okay, I think I'm pretty fast. So that's maybe the meat for user review. Why do we use that? So why do we, or when do we use CDSE and why sometimes not? So first of all, that's of course the critical thing. We need access to the EO products. You can imagine if you are contracted for delivering Copernicus data on time, then you are relying on the data as inputs. And of course, that's the very idea of CDSE, having all data in one place. And I think that's well done. We are very happy with that. Then the second ingredient, of course, it's scalable compute. So we know that data local processing is faster. We don't have to explain that. And since the data volumes are increasing, we are happy to process in the cloud if it's competitive. But of course, if you have large, like for the Fire CCI, you cannot or you don't want to download the full archive. So it's clear that you have to be data local at one of the providers there. Then technical support, if things go wrong, then you need someone that helps you. I think that goes without saying, and it's somehow together with the last point. And that's not a small one for us, I have to say. We have been successfully working with actually all of the partners of CDSE. Interesting, when I put them there, I noticed that we've been in one or the other contacts working with every one of you. So, and we like that, and we know that we can rely on this support whenever we have an issue. And I think that's a strong point. Okay, when not? So when do we decide not to work on CDSE? We have a pretty large on-premise processing cluster. So several thousands nodes, petabyte scale storage, air conditioned, whatever. So we know how to do this at home with our own processing system. And when data transfer is manageable, or when it's maybe not time critical, or we know pretty well what to do, then of course on-premise is cheaper. That's the truth. And I think since we have a lot of processing tasks, that's still a model that we actively pursue. So we do on-premise processing. In the past, there have been because we've been actually seeing CDSE mature, and we've seen several smaller and not so small issues that prevented things from happening. I listed some of them there. So missing services or weak performance. Like in the beginning, Kubernetes availability or Kubernetes as a service or specific flavors, spot pricing models, performance or reproducibility of catalog requests, these kind of things. Sometimes in the beginning, scaling was an issue. So it at some point stopped scaling. But the truth is also that CDSE has matured substantially. So most of these issues are gone now, I have to say. So that's very good. And then, of course, there's the other elephant in the room, the hyperscalers. There might be other commercial alternatives that are cheaper. Or maybe they don't have the data. Maybe there are other constraints. Sometimes the customer requires us to be on one or the other platform. If you work on Destiny, then you have to work on Destiny platform, these kind of things. So there might be reasons why we are not always on CDSE or on Cloudflare, on Creodice, sorry. Yeah, so the conclusion, overall, I have to say we are a satisfied customer and user. So user of CDSE and customer of Creodice correctly. And we rather leverage these low-level services you've seen and reliable data access. And reliability, scalability, affordability, quality of technical support are the most critical ones. Of course, if you don't have that, you cannot sign a contract with, for example, Copernicus that you are able to deliver. And also, if you compete on price, for example, for Copernicus services, affordability is a factor, because in the end, price is often a factor in the evaluation of the tenders. So then we have to also see that the prices for which we buy the services are affordable. And yeah, I'm happy to be able to draw a positive conclusion here. We are really looking forward to continue working with and CDSE and on Creodice and expanding this. There's this ecosystem. We consider becoming a service provider on our own, also visible to outsiders, so that we may have processing as a service or products or whatever will the future bring. So we are looking forward to that. Thanks very much.
Hello, good afternoon, everyone. Can you hear me? Can you see my screen?
Yes, we can hear you.
Amazing. So a couple of months ago, me and two of my colleagues, we attended the European Big Data Hackathon. There we were tasked with coming up with an innovative usage of satellite Earth observation data. And this is what we came up with over that long weekend of the event. We tried putting ourselves into the shoes of a farmer who, let's say, experienced intense drought last year. We tried asking ourselves, how would such person decide what to plant this year? Would they plant a different variety, or would they plant a different crop altogether? How would they ensure that their crops thrive despite unpredictable weather conditions? Today, we're excited to present a proof of concept solution that leverages observation data and spatial analysis to support agriculture and food security. Our team used the Copernicus data space ecosystem to generate actionable insights for farmers, traders, and policymakers. So why any of this matters? Well, because agriculture is the heart of food security, and climate change is making it increasingly difficult to plan for the future. So our work directly supports the EU agricultural policies, including the Common Agricultural Policy, which helps allocate subsidies based on drought risk, and the EU Climate Adaptation Strategy, which aids in climate resilience planning. By making data-driven decisions, we can help farmers adapt to climate change, maximize yields, and assist traders and policymakers in forecasting and resource allocation to ensure a stable food supply. So this is all of the data that we used. So we used the data from Sentinel-1, 2, and 3, as well as some additional data from Copernicus Data Store, air temperature data from the ERA 5 urinalysis data set, because at the moment, at the time of the event, air temperature was not available in any of the Sentinel data sets. So soil moisture data from Copernicus climate data store, some OpenStreetMap data, and other additional data sets. We developed a dashboard that we selected 2 regions, Lithuania and Poland, and we mapped all of this data and our calculated indices on it to make it interactive and visual, and make it a useful tool, proof of concept, let's say. So let's move to a little demo of what we came up with. Yes, so as I mentioned, so to make informed decisions, we analyzed climate data, climate and soil moisture data. Specifically, we used land surface temperature from Sentinel-3. As you can see here, it's historic data from 2023. Let's select May. As well as air temperature at 2 meters, and moisture data. Yes. Which we got from Climate Data Store. So this information helps us understand how environmental factors influence crop growth. Why is this data relevant? Well, first, high land surface temperature combined with low soil moisture signals drought risk, which is crucial for early warnings. Second, this data could help optimize irrigation schedules, allowing farmers to use water resources efficiently. Finally, by mapping temperature and soil moisture trends, we can identify optimal planting zones, feeding directly into our Space Planter tool, which I will show a little bit later. So let's take a look at how we refine this data further to create 2 new unique agricultural indices. Yes, so to detect declining soil quality and climate risks, we created 2 new indices, Drought Stress Index and Thermal Anomaly Soil Moisture Index. So the Drought Index, DSI, measures vegetation stress using 3 key indicators: normalized difference vegetation index to assess plant greenness, normalized difference water index to track water content, both of which we calculated from Sentinel-2 data, as well as soil moisture as a baseline. So high DSI values indicate drought stress, where vegetation is struggling due to the lack of water. Low DSI values suggest healthy crops with sufficient moisture. We made this index to align with the common agricultural policy to help policymakers allocate subsidies based on drought risk. The thermal anomaly index, on the other hand, is used to detect heat wave-driven soil moisture stress. By comparing land surface temperature and air temperature anomalies to soil moisture, this index helps us see how extreme heat affects soil drying. So high index values here show extreme heat intensifying soil dryness, while low index values indicate that soil is retaining moisture well, even in extreme weather conditions. This supports the EU climate adaptation strategy by guiding climate adaptation funding to heat-stressed areas. So these indices are crucial for early drought detection, irrigation planning, and resource allocation. By incorporating them into our analysis, we enable farmers to optimize irrigation schedules and governments to allocate drought relief funds more efficiently. Now to the fun part, Space Planter tool. Now that we've covered climate indicators and drought stress indices, let's move to our decision support tool, Space Planter. This tool maps ideal planting zones based on climate and soil data, helping farmers make better decisions. How does this work? Well, Space Planter evaluates temperature, soil moisture, and other climate factors to determine the ideal crop growth conditions. So for example, here we're looking at Lithuania. Let's say, want to plant potatoes and looking at historic data in 2023, in the month of May, these were the areas where planting potatoes where there were ideal climate conditions to plant potatoes. Yes, in the future, it can also be expanded to not only identify where conditions were perfect or are perfect now, it could also be help to predict where they will be ideal, for example, in the next planting season. Yes, so for example, our potato planting maps, potato planting stability maps, which we have for Lithuania and also Poland, show exactly where conditions line with optimal climate parameters. Additional, this tool could be expanded to recommend alternate crops, alternate crop varieties. So we can go even more specific on a different potato variety, for example, if one is not as climate resilient as another, helping farmers to adapt to shifting weather conditions. So who benefits from this? So farmers, obviously, this tool could help maximize their yields. This could be useful to traders as well. They could estimate future production, as well as policymakers who could use this tool for strategic food security planning. Now, let's take a look. We also did spatial analysis to enhance our approach. Yes. So beyond temperature and soil moisture, we needed to ensure that we are mapping realistic agricultural opportunities. So this is where spatial analysis comes in. we refined our insights by filtering non-agricultural areas, such as urban zones, water bodies, protected lands. Then we aggregated data at different territorial levels, such as grids, NUTS2 and NUTS3 regions, to provide a clearer regional planning perspective. Our key innovation here was the location quotient, a new metric that measures relative agricultural suitability. So LQ allows us to compare regions and identify which areas have higher potential for crop production. So let's say an LQ value of 1 means area is as suitable as a regional average, and LQ greater than 1 suggests a highly suitable area for crop production, while value below 1 suggests lower viability for agriculture. By comparing our 2023 and 2024 maps, we identified shifts in crop suitability due to climate variability. This analysis supports better resource allocation for farmers and helps policymakers adapt strategies in alignment with the EU climate adaptation strategy, which promotes nature-based solutions in high-risk areas. So to conclude, using Earth observation data, we have built a dashboard. We have built a dashboard integrating climate, soil, and crop data. We created 2 new indices, DSI and a thermal anomaly soil moisture index, to enhance drought monitoring and heat stress detection. We created a spatial analysis framework for data-driven agricultural decisions. So what's next? Further improvements for this proof of concept could be to scale this methodology to other crops, other regions, integrate real-time satellite monitoring to ensure continuous updates. And so in conclusion, by combining different types of Earth observation data, we can create actionable insights that drive smarter agricultural policies and business strategies. Thank you for listening.
Ričardas, thank you very much.
How do you primarily access Earth observation data? We tried to go ahead and start answering. We tried to narrow down the options in CDSE to these 3 sort of main approaches: using a cloud platform, using a specific API, or downloading from a specific portal. Of course, for download, you can use an API like OData, you can use the download service, you can download individually in Copernicus browser. So there are sort of gray zones between these, but we really want to see, you know, how much is how many users are going for the platform approach, how many people are still downloading. We've seen use cases where downloading is well justified. We've seen people moving slowly from download to cloud processing or APIs. Yes, we have a question over there.
You also use an API for download. Is S3 an API?
Yes, it's an API.
Catalog, because then eventually everyone uses APIs, right? Somehow.
Yes, I understand your question or your remark from a technical point of view, and I think you're totally right. But this also probes a bit how people feel. You know, do you feel like you're at the download approach, or are you using APIs? Is the API crucial to you? Like, is it important for you that you are using OpenEO, or is it more like the platform approach? Yes, this is. I mean, it's very difficult to ask this question formulated in a correct and easy to answer way. We have 38 answers. Still, I think we can do better. We can have more. But we see that cloud platforms, CRDS and CDSE and other cloud platforms are in the lead. And again, meanwhile, keep checking the existing Q&A questions, upvoting, downvoting, and adding your own. So far in the Q&A, we have something like 10 questions, not that much. So if you don't ask them here, then we're going to have a very short Q&A session, which is not a bad thing necessarily. But once more, the option is here to ask a question live, of course, but it's better to type it into the Slido because that means that other people can also upvote, downvote, refer to it. Maybe somebody wants to ask the same question and then they just upvote yours. So let's use the infrastructure that we have. And with that, let's move over to the next poll, the third one. This is to make a wish, right? We have 6 Copernicus services. We have onboarded land monitoring service, and we're working to completely onboard it. But which are the other ones that you would like to see onboarded? What would you wish for? Well, we won't promise we do it by Christmas, but it's important for us to see the priorities. So far, climate change services is strongly in the lead, which is not a surprise. They are serving good data and it's not so easy to access. So I think this is very, very clear feedback also towards ESA and the Commission on what to prioritize from us. Maybe one day we will have all 6 services directly onboarded to CDSE and you will be able to access all of that in the infrastructure. We would be delighted to have that, but we have to set priorities also due to our capacity. And so this speaks for climate change services. I'd just like to see whether we have new answers coming in. Still in progress. Okay, let's move over to the Q&A, and I'm going to go in the order of up and down votes. So again, don't hesitate to add new questions as we speak. Don't hesitate to upvote, downvote. We would like to see how this goes. So the first one is a very generic question, actually. Whom can I reach out if I have an additional data request for a project? There's several ways to answer this, and several people can answer this. Because for some projects, maybe you want a specific additional data set onboarded to CDSE, or you want to access additional data sets beyond CDSE, such as high resolution commercial data. And then that's different approaches. I would like to speak first about the ESA Network of Resources program, because this is a really, really easy way to go towards requesting additional data that's not necessarily available in CDSE. This program funds data access. It funds experimental or pre-industrial or outreach-oriented development in processing credits or in data access credits. And so if I would be starting a project that needs data outside CDSE, then I would reach out to the NOR portal. I would start an application. It's also a rather simple 2-stage process. So relatively easy to gain support there. And then you can find additional data through that. But I would like to answer or ask our people sitting at the desk, who else can we ask?
Maybe as a remark from my side, so it's Uwe speaking from T-Systems. So there's always the possibility to also use commercial data, which you can actually get through CreoDias. That would be one possibility. And you should also be aware you can also bring your own data if you have your own data, and if you're working in one of the cloud platforms, it's no problem to just use or get your own private S3 bucket where you can integrate your data and you can use them as well in your processing chain. I'm not sure, maybe somebody else, do you want to add to this? Or?
No, I think
okay.
You can also submit a request to the CDSE support team.
Good point. Yeah,
that's always a good point again. Also, because then other users will see that this is an important.
Or open a thread on the community
or open a thread on the forum. Yes, exactly. The next question topping the leaderboard again. Why are we not surprised? Is there a plan to integrate full historical Landsat data within CDSE? And before I move over to the people who answered this, I have to elaborate a bit more on this, because Landsat data comes in different flavors or different aspects of it. Historical Landsat data is one part, and people who work with long-term time series before Sentinel data are, of course, interested in historical Landsat. then there's also a bit of a, we keep getting nudged to integrate current ongoing Landsat data for Europe or globally. Or even subsets of Landsat data, like only the thermal data. But this question is about integrating full historical Landsat data all the way back to the 1970s. Are we planning to do this or not? I don't know. Razvan, maybe you could be the first one to answer.
So maybe just to state that today we have Landsat data in the CDSE and it will be available to users from within the CDSE. It's Landsat data from 2021 until 2025, until today. We are continuously adding new Landsat data. For the historical Landsat data, it's still under discussion.
Yeah, maybe I will add to this, Musha from CDSE, just to that there will be also available quarterly and maybe monthly mosaic from Landsat from 2099 onwards through the Open Geo Hub project, and they will come soon in the CDSE.
Okay. Can I ask the tech team to show the questions on the screen in the order of upvotes or popularity and not in the order of recency? Because the next question actually in terms of popularity is also a really nice one. Is there a possibility for me and users to share a new collection through CDSE? And we are super happy that you asked this question because of course the answer is yes. So it is possible to create a bring your own cog collection using the BIOC API. It has to be in an S3 bucket, so somewhere on CrowdDS ideally. And then if it's a cog, then you can ingest it. And then you can prepare a configuration with that data collection that you can directly share with other users. So you can actually also make one completely public. If you go to the Jupyter lab and you look at the soil erosion notebook, that actually has a custom data set on slopes, which is a cog that's completely public. But it's also possible to share it individually with separate users. And we are really hoping that people will make the most of this opportunity. But can I hand this over to you, Jan, for further details?
Yeah, so now the onboarding scenarios will be completed. So for example, if you are a provider of CCM data, there will be a specialized way for you, way forward to add the data, integrate your data into the CDSE. If you would like to see your data in the browser, it's not that simple in a sense that, first of all, within the CDSE, the data have the EC and ESA quality stamp. So as you can see from the user survey, most of the people are, majority of people are very happy with the data quality. So that's why we are just ingesting the data that we know that the quality are good. So this is something to be considered. So we are not ingesting all the data. If you would like to have the data for your own usage, for example, you are lacking some data in the OpenEO processor or just through the S3, you can use the bring your own cog or ZAR as Andras has mentioned.
Anybody else want to add on this?
If I can add to that, because I think the user is asking about sharing data with the CDSE community. So we're discussing mostly about ingesting data and indexing data in the CDSE, but there are additional possibilities we are looking at federation, at pointing into the stack catalog of CDSE to other external data sets, and also looking to, if you'd like to expose your data and services through the CDSE. So one of them is federation, another one is onboarding your data on the CDSE as well. So third parties can do that, and we'll have a session this afternoon going into more details on those aspects.
Any other comments on this? Do we move to the next one? Actually, again, once more to the tech team, is it possible to show the questions on the screen in the order of popularity? Okay, so The next most popular question is, will CDSE infrastructure be able to keep up with the increased load due to increased user uptake? Any concrete actions on this? Should we be worried about this? I'm asking OTC and CrowdS people to how are we in terms of the available capacity and the current user needs? Do we have more space, or are we coming close to the limits? How are we going to grow?
Maybe it's a general remark. Of course, capacity management is one of the key things here, and we are constantly looking into this. How can we balance in the best way the resources? And I mean, we are really looking into this very seriously, making sure we do keep up with all the developments which we have. And so from that perspective, I can say you should not be worried about it. It's something we are really looking at and making sure it's going to happen. Maybe, Jan, if you want to complement.
Yes, so this problem can be split between the hardware and, let's say, software or API level. So at the hardware level, we are already adding new hard drives. Our storage clusters are scalable, so we are adding new endpoints and disks just to manage the capacity. Regarding the API access, as I have already mentioned, we have improved our download service. So we are making our APIs for downloading and accessing data faster. In the future, we will also now upgrade the cluster behind the catalog, for example. So we are working on both levels, on the hardware level and API level, to keep up with the increased load on our servers. Okay, thank you.
Do you want to add something, Dennis? Or okay, the next question is actually about Google Earth Engine. So a lot of PhD students who still use Google Earth Engine, how we plan to reach them, how we plan to do outreach. This is directed towards me a bit. This is an outreach question, so I'm happy to answer it. The first answer is we are actually very actively working on outreach towards primary schools and high schools. So we are working with the teacher community to create teaching resources that people can approach or people can use to work with very, very young people. We have already some really nice use cases for 10 to 12-year-olds with Copernicus data space ecosystem. So we hope that in the future, people will sort of grow up with satellite data and this public European infrastructure. We are also, of course, very closely working with a couple of universities who have training programs on Earth observation. And now they are moving to port these from the portal or the infrastructure that they have been using to CDSE, because it's also in their interest. It's free. It's easy to use. It has all these steps that you can use for learning. So this is the other thing. Yes, we are very actively working with universities, and of course we hope to use events like these to reach out to the PhD student community. It's going to be a while until we reach such a broad community as Google Earth Engine did, as they were sort of the first ones. But as you've seen in the reports from the European Association of Remote Sensing Companies on industry level, this is already happening. So I guess sooner or later, industries will want to employ people who have experience with CDSE. And if this feeds towards the job market, it's going to create a pull also towards the universities. Anyone else want to comment on that?
Yeah, maybe comment from my side. Like we can also see that many of our users are going towards the open source solutions. With Google Earth Engine, you have Google Earth API, which is a little bit of vendor locking, so you cannot put it on other clouds. Whereas we are mostly using the OpenEO technology, which you can deploy wherever you want, even on your laptop, if you wish. So in this way, it's more open and available to broad public.
Okay, moving on to the next and maybe the final question before the lunch break. Which of the APIs for data streaming is recommended? Which API is the most capable? Well, if there would be a straightforward answer to this question, then we would only be serving one API in CDSE. Of course, different APIs have different advantages, and some of them are fast, some of them connect well to legacy systems, some of them have very, very high capabilities in terms of interoperability. So it actually depends a lot on your use case. It's really, really worth for people who work in coding, the first thing you do is you actually formulate what you want. And if you know that, then you start collecting the tools for it. It's very much the same for APIs on CDSE. If you have a good idea of what you actually want to do, what you want to be compatible with, that's going to tell you about the API to use. In terms of the diversity of processing tools you can apply, I think it's very difficult to beat OpenEO because, of course, you can use your own code. What we see in the dashboard is that a lot of our users are, or most of the processing units are consumed in Sentinel Hub. Of course, a lot of this is because of the browser, but also because this has this very simple 1, 2, 3 steps of catalog, process, statistics. That's sort of easy to understand. But probably most of the data, as Cloudflare colleagues tell me, most of the data is probably moved through S3 because that's like a very simple, very straightforward thing to do if you're actually working to download data. We could talk a lot about this, but maybe people want to add some more comments. Dennis?
Yes. Yeah, so I want to comment because I got similar questions during the coffee break already. And yeah, people asking me on what should I use, and it's not a straightforward answer. It's really depending on the use case. So therefore, it's, I think, important to experiment with the different API interfaces, and specifically for streaming, you have Sentinel Hub and you have OpenEO as flavors. And there's let's say, a generous free tier available where people can start experimenting with, and it's also monthly replenish this quota. So it's very important that you start experimenting with it, what the capabilities are and so on. And I've seen in the first presentation of this session that people are doing that and weighing the pros and cons. So I think it's very important to start at that point. And what I would also like to add is we have these new chatbots coming up. So the Copernicus chatbot that can also be an entry point to start asking questions on what you want, your requirements, and that it can propose already a set of sample code that you can start using and tailor to your needs. So I think there is already some entry level that is lowered in the last few months to start using these streamlined services for your needs, for your use case.
Thank you. Anything else to add? What if we just move over? We have 1 more minute to the top question right now. The difference between image downloading with OData and the new CDSE download service. I think this can be answered hopefully rather shortly. It's from a person called Captain Jack Sparrow.
Yes, basically within the OData you have this zipper link, and the zipper service has been upgraded. So within OData you have already this new download service, and the difference between the previous download service is that now the zips are 64-bit compatible, whereas in the previous edition this was the 32 bits. But mostly it's pretty transparent for users. They are just getting data quicker.
Thank you for your activity in the session, for the questions and answers. And we are really happy to have you here. And please stay with us for the... What? Oh, sorry. Please.
No issue. Just one point, because from the beginning, there was question on the different onboarding. I'd like to react to that. I think what matters from the user's perspective is to be able to use the Copernicus data and the Copernicus information from the services. The question on the onboarding is something else. The question is how the user can really make use of all the Copernicus generation of information and data. So sometimes onboarding is the way forward, and there are good opportunities because of the specificities of the services. Other times doesn't make sense, but what makes sense is that the user are able to cross-fertilize all of those data to use them. So this is part of Copernicus family. It's important that things are working in the different platform, and that we can achieve the federation, the access, and the cross-fertilization. Something else than having different data sets which are not part of the Copernicus family, where it is important to have them talking about very, very high resolution data, which is really good to have them inside. You're talking about students, it's also available to students. So there are specific scheme for those to be there, Landsat the same, and other to come as well. So I would make really a difference in where we can have a common view and common approach to the access and cross-fertilization, from bringing your own data or onboarding data sets which are not part of this one. Thank you.
Okay, thank you. So just keep adding the questions. We will move up to them in the second interactive Q&A session. And with that, thank you to our panelists and thank you for joining, and we will open the lunch break.